Hello everyone and welcome back to another video of the Hidden Quantum Champions. Minerals and materials in general play a very crucial role in today's technology development. Think about electric cars that need, for example, silver. You're looking at the gold prices, which have been increasing so much over the last couple of months, or also the rare earths, which are seen as a crucial, even strategic thing in today's world, especially with the current geopolitical situation. The other things like oil and gas exploration are also very important. And today we are looking at a company that is using quantum technology or offering quantum technology as a way to enable us to explore resources more efficiently, probably more accurate. And that is by the means of quantum sensing, especially using the Earth gravity to actually measure what, or to help us to explore these materials. And if this sounds interesting to you, if you want to learn more about it, if you want to learn more about the company, which is called Nomad Atomics, then stay tuned for today's video as we are diving deep. And as per usual, I want to start the video with a little request for you. So if you find these videos interesting, please make sure to subscribe to this channel so you don't miss out on the next very interesting company from the space of quantum technology that I'm going to show you. But with that, let's dive right into Nomad Atomics. So here we are on their website as per usual. It says unparalleled insights through quantum sensing. Quantum-enabled end-to-end services empowering critical decision-making across industries. So, using quantum sensors to make informed decisions. Now, quickly about who they are. So, Nomad Atomics is a vertically integrated technology and geophysical services company pioneering the next generation of quantum sensing. Our deployable quantum absolute gravimeter leads the world in size, weight, and power efficiency, enabling access to environments beyond the reach of conventional sensors and unlocking new applications. With end-to-end capabilities spanning in-house development, manufacturing, deployment, data collection, and analytics, we provide new insights that empower critical industries, from accelerating mineral exploration and enhancing cave mine monitoring to advancing groundwater modeling, CO2 storage monitoring, and leak detections in water utility networks. Now, the technology that they are using, Nomad Atomics has developed the world's first absolute quantum gravimeter, especially designed for field survey operations. It provides a step change in capability over current survey gravimeters and combines the portability, speed, and ease of use of survey-grade relative spring gravimeters with the precision and long-term stability of state-of-the-art absolute quantum gravimeters. Access to this device is available through Nomad Atomics integrated geophysical surveying service. So the company is not selling these directly, at least not for now, as far as I understand here. But these devices, and you can see one probably here, looks from my point of view pretty portable. They can be basically accessed via their service offerings in these different spaces that have been mentioned before. Now, what are the industries, right? The ones that we see here is mineral exploration. And from my understanding, that, for example, also touches areas like rare earth metals, which from my understanding are minerals in a way. And then, of course, also cave mine monitoring. So time-lapse gravity for visualization and monitoring of cave mines. And then there's a news section down here as well. And I think the usual call to action to look for the open positions and the get in touch functionality. Now we've talked, let's say, a little bit about the problem, about the company. Let's look into the technology and what is actually the offering and what can we expect from this kind of quantum sensor, right? So here we see it. The machine is called Absolute G. So here you see the, let's say, mathematical symbol, the G in these two lines here, vertical lines, is called an absolute. So usually that means you are, let's say, removing the for sign. Maybe for a vector, you're also removing the direction. So you're basically looking at the absolute number. Now, What is it all about? Let's quickly read this text here. So Nomad Atomics has developed the world's first absolute gravimeter, specially designed for field survey operations. Absolute G provides a step change in capability over current survey gravimeters and combines the portability, speed, and ease of use of survey-grade relative spring gravimeters with the precision and long-term stability of state-of-the-art absolute gravimeters. Access to this device is available through Nomad Atomics Integrated Geophysical Surveying Service. That one we've seen already. Now let's look at the metrics down here. What do we have? So weight is 15 kilograms, so can probably still carry that in a hand with you if you want to. So I would say it's probably not a device that you want to connect to a little pocket drone, but more like a bigger drone if you want to put it on a drone. But it's also not a device that you need a truck for, right? It's 15 kilograms. It probably fits in a suitcase. It can run for 5 hours, it says, and it's hot swappable. So you can basically, it's powered by a battery, and you can remove the battery and put in a new one without having to shut it down and restart. So you can measure basically for an infinite amount of time if you always keep exchanging the batteries. Now it becomes interesting. So we are looking at the accuracy and the precision. So the precision is in the 5 microgal, which is for Galileo, in 5 minutes, and the 5 microgal accuracy in general. So what does that mean? A Galileo is, from my understanding, I'm not an expert in that, 1 centimeter per squared second. Now, what is this about? So usually when we are measuring in metric units, we have the meter per squared second. 1 meter per squared second is an acceleration or a gravity measurement. Yeah, basically it's an acceleration speed. If you let something fall in Earth's gravity, it falls roughly at 10 meters per second. Now 1 Galileo is 1 centimeter per squared second. So 1 meter per squared second is 100 Galileo. Earth's gravity is about 1000 roughly. Now, if you are looking at the variation of Earth gravity, you will probably find that it's in the, let's say, 20 of these Galileo units. So what does that mean? Well, there are certain areas where you might be a little bit closer to the pole, depending also on the material that is below you, if it's water or if you have a mountain below you, if there's like heavy stuff below you or light stuff. The Earth gravity is fluctuating or not stable across the whole Earth's surface. It's not just a unit value. There are also maps of this, very interesting to look at. So I encourage you, if you're interested in that, to check it out, where they have basically over-exaggerated the effect, and then you can see at which position in Earth you have what type of gravity to expect. Now, if you, for example, have a very metal-rich area below you compared to, I don't know, just sand, metal is heavier, and that means the gravity will be a bit stronger. If you are, let's say, closer to the center of the Earth, that might also have an effect, right? Depending on where you are, this can all affect, right? And now the precision of this instrument is in the 5 micros, so 10 to the minus 6 of these centimeter per squared second. So it's a very precise system, a very precise measurement, and it measures in 5 minutes. So you don't need to put it somewhere, keep it there for 5 days to do its measurement, but rather you put it there, 5 minutes, you take the measurement, you move on to the next spot. And now you can imagine that this is a very interesting instrument to discover various types of ground scenarios, like mentioned before, water leakage, right? Let's imagine you have a pipe that is running below the ground. Now you can basically follow along with this device the connection or the direction of your pipe. And if there was a heavy water leakage, then of course you would accumulate a lot of water under the ground, and that would have an impact on the gravity that is already enough so that this device with its very high accuracy can actually measure that, can sense that, and then you would be able to see that. Or if you have, let's say, a big oil field below you, that will create a local variation in the gravity, and that's something which you could measure. So this could be used for various types of explorations of minerals, of whatever, right? By using the local gravity on the ground. Now, what are the advantages of such a system? Probably the precision is one of them. We've talked about that before, but there are also other ones. The efficiency, so you have a single operator use, short acquisition time, right, 5 minutes. It's light, only 15 kilograms. It's robust and easy to use. Then you have the indefinite measurement window, so no instrumental drift, allows continuous operation or repeat deployment for time-lapse data acquisition. So because of the fact that it's using quantum properties for measurement, it does not come with a drift. There's no electrical sensor like an acceleration sensor or anything in there which drifts over the course of time, but it's using the fundamental properties of quantum mechanics to actually measure. It's not stated here how it actually works, but probably, no, I don't want to make a statement. It's not mentioned here how it works, but there are different ways. Like you could, for example, use Bose-Einstein condensates. We've seen that before as one way, but there are also other ideas of how to measure gravity using the properties of, let's say, quantum mechanics. And then if you're doing so, you're not experiencing any drift over time because you're basically using the fundamental properties of a material in quantum physics, and therefore, there's nothing that can actually drift. There's no solid state, no sensor that can experience temperature changes that are not properly compensated and therefore lead to drift or anything like that. Precision, we've talked about that, right? 5 micro Galileo in 5 minutes for the measurement, and then accurate, so data set are absolute and offer drift-free measurements that enable comparison across different locations and times while eliminating the need for tie points and reference sites. And then low impact, so low destructive, because you're not drilling any holes in any ground or something, right? And passive technique with no additional infrastructure required, so you don't need to dig holes or anything like that, right? You just put it on the ground and measure. This is the result of many years of research and development and is enabled by Nomad Atomic's proprietary technology. Then the services, we've talked about them before, mine exploration and cave mine monitoring are some of them, and there are also emerging services which we are going to touch right now. Let's quickly go here to the overview of the services. So just to see what are actually the things that this is used for. Mineral exploration, I briefly touched on that. Efficient, accurate exploration is critical for unlocking new resources and reducing the cost of discovery in increasingly complex terrains. Nomad Atomic's quantum absolute gravimeter deliver drift-free high-precision absolute gravity data, removing the need for repeated calibration and complex correction workflows. This not only accelerates data acquisition and processing, but results in improved data confidence, empowering exploration teams with faster, more reliable insights. Cave mine monitoring allows for productively manage geotechnical risks such as air blasts and expert more targeted control over extraction, leading to safer operation and improved performance. And then the emerging services that we see here, absolute gravity networks, carbon storage monitoring and verification, groundwater monitoring. We've touched briefly on the leak detection, off-world expansion, so in the space, and then drone-assisted gravity surveying that I also briefly mentioned before. Now let's quickly go into the first one here, because that might be an interesting thing as well. So emerging services, absolute gravity networks build the foundation of everything else. So absolute gravity stations and networks are critical infrastructure that provide baseline data for accurate gravity surveys, underpinning everything from mineral exploration and groundwater monitoring to geohazard detection and infrastructure planning. Nomad Atomics offers a first-of-its-kind service to establish, upgrade, and support these networks using our compact absolute gravimeters. Designed for remote deployment and long-term stability, our technology removes the barriers of cost, fragility, and complexity, bringing gravity networks within reach for regions worldwide. So the idea is that you put a couple of these devices around and that you just keep them up and running over a long period of time and monitor how things are changing. Because these devices are drift free, you are not expected to see any, let's say, change in the data as long as nothing is happening. Now, if you, for example, have a big leakage somewhere, you will see that values go up. There's also movement of the Earth itself, right? You have the crust that is moving, that is kind of swimming on top of the, let's say, core of the Earth. And there are local variations also because of that, which might even be interesting to predict something like tsunamis or earthquakes or anything like that, right? I'm not an expert in that, but I think this might be very useful data. And in the past, I think it was very difficult to actually harvest this data because you needed to have somebody who's going to these machines, making sure that they are drift compensated, so calibrating them somewhere, then putting them back into the field, and that makes it very cost intensive and very difficult to deploy those. But now it seems like with this change towards the quantum sensing and the drift free deployment of these devices, it is probably a bit easier to have these, and probably it's a valuable data point. Now there are other ones, and I encourage you to check out these other emerging fields if you're interested in them. We have CO2 here, groundwater, the leakage detection, and then basically space exploration as well as drone deployment. But I don't want to go into these for now. Just quickly hopping into the news section because I'm recording this in April. The last news article that we find here is from 2025, June 18th, that is linked here. So I think it's a little bit out. And also here we only see 2025. So not sure how active this still is looking at it. Well, as a last thing, also quickly check out the About Us part of the website. So at Nomad Atomics, we transform the complexity of quantum science into powerful technologies that drive progress across industries that matter. Our mission is to revolutionize sensing by making quantum technologies the most sought after solution for the world's most challenging problems. The vision to enable the safe exploration and pursuit of knowledge in the most challenging frontiers of our world and beyond. The values are innovation, trust, and excellence. Innovation is innovation at Nomad Atomics means thinking differently. We actively explore new ideas, adapt quickly, and deliver cutting-edge solutions designed to give you a competitive advantage. Trust comes from action. At Nomad Atomics, we respond quickly, speak plainly, and follow through, so you can focus on results, not uncertainty. And then excellence means attention to detail in everything we do. At Nomad Atomics, we hold ourselves to rigorous standards, ensuring the services we deliver are constantly at their best. Now quickly about the story. At Nomad Atomics, we are turning quantum technology into real-world solutions. We started as a bold vision. What started as a bold vision has grown into a company leading the way in quantum sensing. We've evolved, so has our team, bringing together people with diverse skills and perspectives, all contributing to our success. Together, we are developing cutting-edge technology that delivers critical insights across industries worldwide. Our journey is built on a foundation of pioneering research at the Australian National University and Humboldt University of Berlin, where our co-founders led some of the most advanced programs in quantum gravimetry and accelerometry. This groundbreaking work is deployable sensors and navigation systems set the stage for Nomad Atomics and continue to drive our mission today. With that, we are already, as per usual, at the end of today's episode. I hope you liked it. I hope you found that one interesting. From my point of view, quantum gravity is definitely one of the very interesting topics in quantum sensing right now. Probably for these exploration type of things, we also have seen this become interesting in the navigation setup. For example, for aircrafts, both in the, let's say, commercial space and also the defense sector. So there is a lot of movement right now. And if you haven't seen the other videos yet, I encourage you to check out our Hidden Quantum Champions playlist, where you find all the other videos of company reviews like this one. With that, I always want to make sure you stay hydrated. So make sure to get yourself something to drink after this little session, and I'm looking forward to see you in the next one. Until then, bye bye.